All right, a well-insulated copper rod, thermal conductivity of 388 watts per meters per Kelvin, is 50 centimeters long and has a cross-sectional area of 10 centimeters squared. Okay, so I wrote the information down here. Here's my copper rod. I already converted units for you here, 0.050 meters and 0.001 meters squared. One end of the rod is in contact with a block of ice. Okay, here's our ice, 0 degrees C, and the other side is contacted with water at 100 degrees C. Okay, they give us two values here. So heat of vaporization, right, liquid to vapor right here, and then heat of fusion value. So the energy that it takes to transfer from um, a liquid to a solid is right here, heat of fusion. So how much ice is melted in 1 minute? Okay, so we have to understand that this heat, it's going to transfer from hot to cold. So 100 degrees C to 0 degrees C. The heat transfer is going in this direction. Um, all this heat transfer is contributing to melting the ice. Okay, so if I were to write that in a formula, Q dot is equal to delta T all over the thermal resistance, which this heat transfer, so this heat transfer is equal to this. This heat transfer is equal to m dot. This is the mass rate of the ice that's melting times the heat of fusion. Okay, the energy it takes to go from a solid to a liquid. All right, the thermal resistance is equal to L all over A and then Kc. And then if I plug this in there, right, Q dot is equal to, I'll go ahead and, so A Kc, and I'll write out delta T, which is 100 minus 0. This is a change in temperature, so I don't have to worry about absolute units. L, and then this is equal to m dot HF. Okay, so I think we have everything. All we have to do is solve for m dot. So I'm going to plug in everything here. 0.001 m squared. Kc is 388 watts per meter per Kelvin. Okay, 100 minus 0. Change in Celsius is the same as the change in Kelvin. L is 0.050 meters. Okay, this is equal to m dot, and HF is 334 kilojoules per kilogram. All right, and if I solve this for m dot, let's see, you will get 0.00023 kilograms per second. All right, so they wanted how much mass in 1 minute. So from here, it's just simple unit conversions. So 60 seconds is 1 minute, right? Times in 1 minute, right? Yep, 1 minute times 1 minute. And this gives me 0.00023 times 60 is 0.0138 kilograms.